Hello student, welcome to our channel. This is Vasanth from Canara Engineering College. In the last class, I have discussed about entity and architecture of VHDL design. I hope it is understood. In this class, we will continue with the small example on half adder. Simple circuit diagram of half adder. We know, like, which contains 4 ports, like 2 input port A and B and 2 output ports sum and carry. As I said in the previous class, entity is used to define the input and output port. So here you can see the entity declaration. So entity and port, all these are the keyword, and half adder is the user defined word. So entity half adder is port. A and B are type of input port and of data type bit. In the last session we have seen the data type of standard logic. So the difference between bit and standard logic is standard logic can contain many values, but bit can contain only values 0 and 1. So here sum and carry are port type of output port and of data type bit. Again end with the entity name. So in this way we declare entity for half adder. Now next we will see the internal architecture of half adder. This is the internal architecture of half adder. We know half adder consists of exclusive OR gate and AND gate with input A and B and output sum and carry. So now we are going to implement this internal architecture design in the architecture of VHDL. In order to implement the internal design in architecture, there are 3 types of modeling are used. One is called as structural modeling, second one is data flow modeling, third one is behavioral modeling. So now what is the difference between structural and data flow modeling? Actually speaking, structural and data flow modeling are used for smaller design, that is both are used for smaller design, and it is used when we know the input and output in clear form. That is, when we know about the input and output are clear, then we use structural and data flow model. But behavioral model are used for larger design, the design which consists large number of gates and circuits. So in other way I can say we construct a larger design by using behavioral modeling with the help of structural and data flow. Now we will see the structural style of modeling architecture. In the structural style of modeling architecture, before begin, we declare component. So here you can see the component XOR1 is declared and component AND 1 is declared. That means we declare separate design, VHDL design, in terms of component or in terms of a structure, or we define structures for the component. Like here you can see there is one structure here, there is one structure here for component XOR1, and there is one structure for the component A and 1. So all these are coming under different VHDL design, and but all these are coming under a single entity. You have to remember this point. Now in the begin statement we use port map to map the different input to the output. We will see this one. Here in the beginning you can see component is declared by the statement using component XOR1 with the port port command, that is a keyword. Component and port are keyword, and XOR1 is the user defined word. Port, here X and Y are the input port of type BIT. I have told you what is BIT, and Z is the output type, Z of type output and of data type bit. So component should end with the end component. Similarly, we define component for AND gate. This is the component for XOR gate. You cannot use the word XOR or AND. This is because all those functions are exist in VHDL database. So you have to use name some other name other than the predefined name like XOR or AND. So for the component AND gate, I am giving user defined name as AND1, and with port U and V are the input port of type bit, and W is the output port of type bit with end component. Once I define this one, I will try to map the input and map all these map A, B, sum, and this is carry here, sorry, this is carry, to these input X, Y and U, V. This is something like this. So here it is something like this. We will define separate design for AND gate, and separate design for OR gate, sorry, XOR gate, and finally we'll bring these designs under big design, that is called as big design with the input A and B, and output is equal to sum and sorry, let me write. So output is carry and sum. So here internally this component AND is declared with input U and V, and this component XOR is declared with the input X and Y, and declared with the output Z. This is declared with the output W. So now by using map statement, we will map here U to A, V to B, X to A and Y to B. Similarly, we will map W to carry and Z to sum. That is, by using for statement, we will map A to X, B to Y and sum to Z. Similarly, we will map A to U, B to V and carry, this is carry not sum, carry to W. So this is the main goal of or main idea behind structural modeling. So now we will see other type of modeling. The other type of modeling is a data flow modeling. This modeling is very simple and straightforward. Here we define architecture architecture with the simple assignment statement by using simple assignment operator or assignment statement. Here you can see architecture with the user defined word of entity of header. This architecture belongs to entity of header. So this statement is not there. Let me followed by begin statement with the sum is assigned with the XOR value of A and B, carry is assigned with the by using assignment operator the value of A and with the B, followed by end statement and architecture name data flow h underscore HA. So with this you can define different types of modeling in the architecture. So let me repeat, there are three types of modeling. One is called as structural modeling, second one is called as data flow modeling, and third one is called as behavioral modeling. Structural modeling and data flow modeling we use when we know the inputs and outputs are in the clear way, but behavioral modeling we use in the larger design. So we can sum up like this. Larger designs we can define by using behavioral modeling with the help of structural and data flow modeling. Thank you.